Hello everyone, welcome to my math class. In this video, we are going to look at the modulus function. We will start with the modulus or absolute value of a real number x, which is denoted as the absolute sign of x. It is defined in this way. If x is greater than or equal to 0, the absolute of x is just x. If x is less than 0, and absolute x is the opposite of x. Based on the definition, we will know that the absolute of 5 is 5. If we have negative 5, then the absolute of it will be negative 5, which is equal to 5. The modulus value of x is also defined as the square root of x squared. If we let y equals the modulus value of x, then we will obtain the modulus function. We will focus on the graph of this function. First, we will consider the definition of the modulus value. Based on definition, we know if x is greater than or equal to 0, we will have the function y equals x. It is a linear line, and we can use 2 points to determine this line. Here, as x can be 0, we can select x be 0, then y will be 0 as well. Then another point, we can use 1, 1. Plot these 2 points and then connect these 2 points. For this straight line, we only keep the part with x greater than or equal to 0. If x is less than 0, y is equal to negative x. And it is a linear function as well, and select 2 points to determine the graph. We will select x equals negative 1, so based on the condition x should be negative. Then the corresponding y will be negative x, substitute x, then negative become positive. Therefore, y value is positive 1. Similarly, we will have x equals negative 2, then y become positive 2. Plot these 2 points on the diagram, and then we connect these 2 points using the straight line. The same, we only keep the part with x being negative. Therefore, we obtained the graph of the modulus function. It has the V shape. Based on the graph, we can see it is symmetric about the y-axis. It tells us the modulus function is an even function. And by using the symmetry of the even function, we can get the second idea of obtaining the graph. For the second idea, in the first step, we are going to verify it is an even function. We will use the function notation to express the function. It means f of x is equal to absolute of x. Then we are going to verify when x is replaced by negative x. So f of negative x is equal to negative x. Then takes absolute value. And this is the same as the modulus of x. Therefore, it is f of x. It means we have verified f negative x is equal to f of x. Therefore, the function is an even function. Then we just use 2 points to determine the graph on the right part of the y-axis. For example, use 0, 0 and 1, 1. Then we are going to refract this part in the y-axis to obtain the other half. So we can use the point 0, 0 and negative 1 to help us refract the graph. So this idea mainly focuses on the feature of an even function. So for the third idea, we are going to start with the original function without the absolute sign, y equals x. And it is a linear function. We are going to use 2 points to determine the line. Then we will connect these 2 points, use a dotted line first. After that, we're going to look at the modulus function y equals absolute of x. If x is greater than or equal to 0, it is just the original one, y equals x. It means for the graph which is on or above the axis, we are going to keep it, and we will convert this one to the solid line. If x is less than 0, absolute of x is equal to its opposite, which becomes positive. It tells us for the original function, the graph is below the x-axis. It will be reflected in the x-axis. Then we will erase the portion below the x-axis. The third idea mainly focuses on the relationship between the original function and the modulus function. These are the three ideas we used to obtain the graph of the modulus function. Based on the graph, we know the modulus function, the domain is the set of all real numbers. We can write as negative infinity to positive infinity. And then the range of this function is the set of values greater than or equal to 0. We can also use the interval to express it from 0 to positive infinity. And 0 is included, we use square bracket, and positive infinity we use a round bracket. Let's move on to look at some composite functions involving the modulus function. We have y1, which is equal to ln absolute of x, and y2 equals the absolute of ln x. The question is, what's the difference between these two functions? You can pause the video and think about it. The first function, obviously, the inner function is the absolute function. We can let this one be u. Then the outer function is the natural log function, can be expressed as y equals ln u. It is the first case when the modulus function is the inner function. We mentioned previously the modulus function is an even function. When it is the inner function, we will get the result that the composite function will be an even function as well. Therefore, the graph of the composite function is symmetric about the y-axis. Then, in order to get the graph of the first function, we can use the symmetry. First, we consider the function when x is greater than 0. Then y1 is equal to ln x. Therefore, on the right part, we will have the natural log function directly. We will use the key points 1, 0 and e1 to locate the function. After that, we are going to reflect the right part in the y-axis to obtain the left part. And this one, it's just idea 2 when we sketch the basic modulus function. Now let's focus on the second function, y2. ln x is the inner function. We let it be v. An outer function will be the absolute of v. In this case, we know the absolute function is the outer function. How can we sketch this? The first step, we will rewrite the function. If the inner function ln x is greater than or equal to 0, then we can get rid of the absolute sign directly. If the inner function is less than 0, then we will have negative sign in front when we get rid of the absolute sign. Therefore, these two pieces distinguished by the sign of the inner function ln x. As a result, we first sketch the inner function y equals ln x. We use the key points 1, 0 and e1 and the asymptote to get the graph. Then we will focus on the part when ln x is greater than or equal to 0. It means the graph is on or above the x-axis. For this part, we are going to keep the graph, change it to the solid line. When the inner function ln x is less than 0, it means the corresponding graph is below the x-axis. For this part, it will become its opposite. It means we are going to reflect this part in the x-axis. And we are going to erase the part below the x-axis. We erase the arrow as well. You may have noticed that when we sketch the second type of function, we used the third idea when we deal with the basic modulus function. Now it's your turn. Please sketch the graphs of the following functions to check your understanding of this part. That's all for this part. Thank you very much for watching.